Hello and welcome back to the cyber education world. In this video, we will be exploring the important distinction between DNS domain name system and DNSSEC domain name system security extension. Have you ever wondered how DNS assists you in navigating the web while DNSSEC ensure the security of your queries? Okay, stick with us as we uncover how these technology collaborate to keep our digital world running smoothly and securely. Okay, now let's start. Now, DNS. DNS stands for Domain Name System. Okay, Domain Name System stands as a remarkable technological innovation operating as a hierarchical system for the domain and IP addresses, streamlining the process of assigning internet addresses. It efficiently translates domain name into corresponding IP addresses. Okay, likened to effectively locating a contact in a mobile device's contact list without needing to recall their actual number. Okay, DNS play a pivotal role in managing and translating inquiries to IP addresses, empowering the identification of various interconnected devices within the network beyond the translation of host name to IP addresses. Okay, DNS fulfill a myriad of functions spanning the definition of port usage, establishment of connection between the services and domains, and authentication of emails. Okay, notably, the DNS system encompasses over 50 type of records, each servicing distinct function within the network infrastructure. Okay. Now, DNS servers types. Okay, DNS servers play crucial role in the process of resolving domain names. Okay, like recursive DNS servers, root name servers, top level domain servers, authoritative DNS servers. Okay, now recursive recursive DNS servers. Okay, these servers handle queries from client and perform the necessary lookup to resolve domain name into IP addresses. They can catch result to speed up the future queries. Okay, now root name servers. Okay, root name server are at the top of the DNS hierarchy. Okay, they respond to queries for records in the root zone and direct them to the appropriate top level domain server. Okay, now TLD name server, top level domain name server. Okay, this server manage the DNS records for domain under a specific top level domain. Okay, such as .com, the organization, net. Okay, they direct queries to the authoritative servers for the request domain. Okay, now authoritative DNS server. Okay, authoritative DNS server. These server store the DNS record for a domains. They provide answer to queries about domain. They are responsible for delivering the most accurate information. Okay. Okay, now how does the DNS work? Okay, let me explain how DNS work. Okay, when you type a domain name like facebook.com in your browser, okay, it first check your local cache to see if you have visited the site before. Okay, if not, it initiate a DNS queries to find the answers. If the page has not been visited before, your computer will seek the answer from your internet provider recursive DNS servers. Okay, these servers also have a cache, so they might provide the result. If not, they will need to search for information elsewhere. Okay, next step involves the name servers. Okay, which act as a intermediaries. Okay, they might not have the answer, but they know where to find it. Okay. The name server read the domain from right to left and direct you to the top level domain server for the extension like .com. Okay, these top level domain server will ultimately lead you to the servers with the correct information. Okay, these server check the DNS records for the information. There are different type of record. For example, if we want to know the IP address for a website, our request is an address records. Okay, the recursive server obtain a record for the website from the authoritative name servers and store it in its local cache. If someone else need to the host record for the same site, the information will already be there. Okay, eliminating the need to go through all these steps. Okay, all this data has an expiration data, ensuring user receive up to the data information. Okay, once the recursive servers has to a records, it send it to your computer. Your computer saves the records and read the IP and passes the information to your browser. The browser then establishes a connection to the web server. Okay, then allowing you to finally view the website. Okay, now components of DNS. Okay, DNS name system has several initial components. Okay, each playing a crucial role in its operation. Like first, domain name space, DNS servers, DNS query, DNS records. Okay, domain name space. The tree-like hierarchy structure effectively categorizes host names into a smaller division known as the domains, okay, which are the further classified into top level domain, second level domain, and subdomains. Okay, now DNS server. DNS server, these servers are responsible for resolving domain name to IP addresses. They encompasses authoritative servers containing the original DNS records. Okay, recursive server that catch and resolve queries, and root name server that direct queries to TLD, top level domain servers, and TLD servers that manage second level domain. Okay, now DNS queries. DNS queries, each request come from a device that demand a DNS record. Okay, it is a questions that run from one recursive server to another in search of the answers. Okay, now DNS record. The DNS store initial information in DNS record, which are the text documentation. Okay, which are the text documentation serving various purposes such as records, SPF records, CNAME records, and more. Now, DNSSEC, Domain Name System Security Extension. Okay, DNSSEC. Okay, DNSSEC is a set of extensions designed to enhance the security of domain name system by verifying that DNS information has been altered. Enterprises can implement DNSSEC to bolster their DNS security. Okay, DNS technology was not originally developed with the security consideration in mind. Okay, example of an attack on DNS infrastructure. Okay, attacker on DNS infrastructure is DNS spoofing. Okay, in this type of attack, an attacker manipulate a DNS resolver cache. Okay, leading user who attempt to visit a website to be directed to an incorrect IP addresses and view the attacker's malicious site intent of the intent site. Okay. DNSSEC is a critical tool for organization to safeguard sensitive data and definition stored in DNS server. Okay, various type of data including IP addresses, mail exchange server detail, and host information such as the CPU and OS versions. And it can be protected by DNSSEC. Okay. Moreover, DNSSEC play a pivotal role in preventing data exfiltration via DNS. Attackers frequently exploit the DNS to circumvent security controls and illicitly transfer sensitive data outside the organization through the DNS servers. This is often achieved by extracting data from an internal server and initiating DNS request to an external server. Okay. Now securing DNS using DNSSEC. Okay. DNSSEC is a technology that definitively verifies the legitimacy of responses sent by name server to client using the digital signature technology. It's add cryptographic signature to DNS record to robustly protect the data published in the DNS. Okay, with DNSSEC, the DNS resolver confidently check the signature associated with a record to ensure its authenticity before serving responses to the client. All records must impeccably match those stored on an authoritative DNS servers. Okay, to facilitate digital signature validation. Okay, DNSSEC confidently defines several new DNS sources records type. Okay, like sources record signature, RRSIG, the DNS keys, and next secure records, NSEC. Now, DNSSEC validation process. Okay, like a user enter a URL address like example.com into their browser. The browser queries the local computer DNS resolver to find the IP address for the hostname. Okay, if the local DNS resolver has the IP address in its cache, it returns it to the browser. Otherwise, it forward to the request to a recursive resolver managed by the Internet Service Provider ISP. Okay, the recursive resolver check its cache for the IP addresses. If not found, it initiate a recursive queries to locate the DNS server that hold authoritative information for the requested domain. The recursive resolver contacts the root DNS server, which then refer to the top level domain server for the domain. For example, example.com. Okay, the global DNS server for all like .com domains. Okay, the TLD, the top level domain server, refer to the resolver to an authoritative name server. Okay, a DNS server that holds DNS records for the requested domain. At each stage, the resolver requests a DNSSEC key associated with the DNS zone to verify the server authenticity. Okay, the authoritative DNS server responds with a DNS response containing resources records signatures. Okay, RRSIG records. Okay, the recursive resolver validates the RRSIG to confirm that the address record was indeed sent by the authoritative name server and was not altered in transit. Okay. It it then sent the validated DNS response within the IP address to the DNS client. Okay. Thank you for watching this video. If you like this video, please like, share and subscribe to our channel for more awesome video. We look forward to seeing you in our next video.